Okay, so in the last couple of lectures when we've been talking about monopoly, we've been fixing the characteristics and details of pricing of the products. We only allowed there to be like one uniform price that everybody paid. And today we're going to talk about the details of how products are designed and priced with a lot more focus. So we'll talk about how to design, price, and market a product or a line of products. And we'll, in the process of that, cover a fair number of the topics that are discussed in the context of mechanism design, contract theory, and other areas, but from a very price theoretic perspective. So we'll talk about some of the tools and goals that firms have in designing their products. We'll then talk about the Spence model, or a version of it that I came up with, which will emphasize the importance of the difference between the valuations of marginal and inframarginal consumers. We'll then talk about Leibniz's rule to solve, and this is the place to solve these models, and this is the place where the most mistakes will probably creep in. We'll then talk about a more specific model, Hotelling's model, and apply that to political competition. We'll then also apply it to an empirical analysis of newspaper slant and to platforms. We'll then complicate that model a little bit by talking about intensive margins rather than just who buys the product, how strongly they interact with it. We'll then talk about the selection power of product characteristics and apply that to the design of subprime credit contracts. And then Tuesday after the midterm, we'll follow up and apply these ideas to theories of price discrimination, which we'll largely view as an application of the ideas we do today. Okay. So in considering product design, there are really two crucial issues. One is, what are the goals that a firm is trying to achieve in designing its product? And second, what are the tools that it is available to do that? So the goals that firms are trying to achieve are to keep costs low and prices high, to attract as many consumers as possible, and in particular to attract consumers who are the most valuable to the firm or avoid the ones that are most costly to them. And the tools or instruments that the firm has available to do this are a uniform price, which is the thing we were talking about for the last two lectures. So that won't be the focus today. Discriminatory or sophisticated prices, which we'll talk about on Tuesday. The range of products offered, which we'll also talk a little bit more about on Tuesday. What we'll focus on today is product quality, the ease of using the product, things like its color, other features, the niche or market segment that the firm tries to target, the way it advertises or markets to consumers or places its products, the groups of consumers that other consumers have to interact with. So the attracting valuable consumers will be both a goal of the firm, but also a tool that it uses in trying to achieve its goals. And today we're going to learn how to use all of these instruments, how the firm will optimize all of these instruments to try to achieve its goals. So a common way of dividing up the tools or instruments that a firm has is into vertical versus horizontal tools. So a vertical tool is something that all consumers agree is good or bad. Price would be one of those, right? But more generally, any sort of thing that's really the overall quality of a good, the speed of internet connection, or the level of insurance coverage. Now, consumers might differ in terms of how much value they put on this, but all of them think it's good. The second type of characteristic is horizontal. This is one that some consumers view as good, other consumers view as bad. And consumers often have like an ideal point, some ideal thing that they would want in the set of horizontal characteristics, and the closer that the firm is to that, the more the consumers will like it. And consumers will be heterogeneous in this. Colors, flavors, designs, styles, political bias, these are all examples of horizontal characteristics. But sometimes and quite often, there are sort of diagonal characteristics which most, but not all consumers view as positive. Most people will feel the same way, but to differing extents. And what determines really whether characteristics fall into these categories is not something inherent to the characteristic itself, but to the heterogeneity of how consumers feel about it. So what makes something vertical is all consumers like it. What makes something horizontal is that consumers differ in terms of whether they like it or dislike it. So really the nature of the heterogeneity of consumers is really what determines whether a characteristic is vertical or horizontal. Okay, so there's three basic effects in the design of products I want to try to highlight today. The first is that firms will try to cater to marginal consumers rather than average consumers. And those are sort of called the Spence and Weil effects. Then the intensity of consumption versus the amount that the firm's able to extract from the inframarginal consumers. So because the firm only caters to marginal consumers, it'll try to extract as much revenue as it can from the consumers who are locked in and inframarginal. But that may cause them to reduce how much or how intensely they consume a good, and that will be a trade-off that the firm will face, and that's called the Musa-Rosen effect. And then the third is that the firm will try to choose its product characteristics so as to selectively attract the most valuable consumers, which is the basic effect that's emphasized in that paper by Andre and myself that I had you guys read. Now, in the paper with Andre, we sort of have a unified model of all of these three effects, but I'm going to try today to add these things in pieces to emphasize each. We'll focus first on the catering to marginal consumers, then on the intensity of participation, and finally on the sorting. Okay, so let's start with the idea of catering to marginal consumers. So suppose that there are many consumers, each of whom either buys the product or does not buy the product. And each consumer gets a utility that depends on some product characteristic X, and then we subtract off the price. Capital theta, bolded theta is the consumer's type, and X is the characteristic of the product. The type of the consumers is distributed according to some smooth distribution F of theta, and anyone who has a utility that's weakly above the price will consume the product. So the set of all people who consume the product are those, again, who have utility above price given X, and we're going to denote that by capital theta of X and P. And another way of denoting this is that we can take the last element of people's type, and if we assume that utility is increasing in all of the dimensions of the type, that is, people with higher types have higher utilities, then the set of all people who purchase the product are all of those who have the last dimension of their type, theta sub t, being greater than some threshold which is determined by all the other dimensions of their type. And the reason that that's a useful way to represent things is it will allow us to do everything in terms of just integrated integrals to figure out the average value or the total value of various quantities. So in particular, the number of people buying is the integral over the set of people who are buying of the density, which is the iterated integral up through all the dimensions over the full set of types for all the dimensions except the last one, and for the last one only between the threshold after which people consume up to the total of the density. Okay. So as usual in price theory, everything is going to be about marginal this, marginal that, and taking derivatives. So to take the derivative of an integral like this, we use Leibniz's rule, right? And Leibniz's rule always has two parts. So on the one hand, there's an effect on the interior of the integral, which in economic terms we call the inframarginal effect or the intensive margin. Miles, what is that? What does that correspond to mathematically in Leibniz's rule?
It's just the integral over the capital theta, and then just take the derivative within the actual integral itself.
Exactly. So that's the derivative inside of the integral of the thing with respect to x. Now that's equal to 0 in this particular case because we're just integrating the density, right? So that density doesn't directly depend on x, But more generally, it might. There might be something in there that does. Okay. So the second effect is the impact on the boundary of integration. And that's sometimes called the extensive effect or the marginal effect. And Russell, what does that correspond to mathematically in Leibniz's rule in this case? Yes. And in this particular case, what would that correspond to?
The theta cutoffs.
Exactly. So the theta cutoff will move as x changes, right? So in particular, this is equal to the negative, because it was the bottom of integration, of the derivative of theta t star with respect to x integrated with respect to the density. Now I'm going to denote that, just for simplicity, by the integral over partial theta, which is the, sorry, I didn't define partial theta, I don't think. Partial theta is the set of people who are just indifferent to buying the good or not. So that's the set of marginal consumers of the derivative of theta with respect to t, of theta star with respect to t. And because this is only an integral over t minus 1 dimensions, not over t dimensions, right? Because it's integral along the boundary, I'll denote that by the integrating thing with by t, little bolded t, which is the way we write all of the dimensions of type as a function of the t minus 1 dimensions of type that we're actually integrating with respect to. So that's t minus 1 dimensions plus the threshold that corresponds to those. Okay. So let me just show you visually what that looks like. So if we had a two-dimensional type space, right, then the set of people who are going to be participating are going to be those that are above some decreasing threshold here. So for any value of theta 1, it's people who have theta 2 above that level that are going to participate. And then marginal people are going to be ones who are exactly along the boundary between those two sets. Okay. So we know that along that boundary, utility is held fixed. Right? Everyone along that boundary has the same utility, which is exactly equal to price. Right? So we can derive from that how the threshold type changes as x changes. How do we do that? Well, we have to partially differentiate this equation. Sorry, implicitly differentiate this equation. So we get that how much theta t star changes with respect to x multiplied by how utility changes with respect to theta t plus how much utility changes with respect to x has to be equal to 0 in order for this to continue to be being equal to p. Tova, can you calculate what that derivative is going to be equal to given this equation? So if we want to find how much the threshold changes when x changes.
That's going to be our u prime times the partial of theta sub t times the partial of theta x. Times.
So it's going to be, this is equal to 0, right?
Yeah. Is that two separate? Sorry, I can't remember.
So this is an equation that says that partial theta t star partial x times partial u part.
Fine, so just u, what's it called? U. Yeah, sorry. U prime times the times partial of theta t divided by partial of u times partial x is equal to.
Yeah, so it's going to be u prime, you bring this whole thing to the other
Sorry, I don't
side.
get the intuition. I don't know how to explain it.
You then divide through
Yeah,
by this, right?
yeah.
And so you get that it's equal to negative u prime over partial u partial theta t.
Yeah.
Yeah.
Sorry if I said it badly.
No, that's fine. So that gives you that this thing that we derived is equal to negative u prime over partial u partial theta t. Now, why does that make sense? Because basically what this is saying is, here's how much utility people get from x. Here's how much it changes their utility when theta t changes. So we're going to have to change theta t 1 unit for every unit that utility increases, divided by however much theta t is moving utility. Right? That's how much the threshold changes when x changes. Okay. So what this says is people are going to be attracted proportional to their marginal utilities for x. People, when we change x, the number of people who come in that have high marginal utility for x is going to be greater than those who have low marginal utility of x. The more marginal utility you have for x, the more quickly the boundary is going to move in that part of the space. So imagine that, the marginal utility for x is increasing in theta 2 and decreasing in theta 1, well then the boundary is going to move very quickly up here and very slowly down here. Okay. So by the same logic, we can derive the number of people who are marginal.
Glenn?
Yes.
So that's one way where the u prime, like how much value you derive, and the other one is the threshold for the derivative of u with respect to theta t.
Yes.
So that would mean that.
So what I said was only true if 1 unit change in theta t has a 1 unit change in utility everywhere. But if some places, like theta 2 is affecting utility more than others, in those places the boundary won't move as much.
Okay.
So you have to basically transform the type space into a willingness to pay space. And you want to move a certain number of units in the willingness to pay space for every amount that x affects the willingness to pay. So that's the key point.
So that you kind of get to uniform that it only depends on the u prime. Or
Exactly. That's sort of what this transformation is doing. Because of course we could always parameterize the same exact utility function in different ways by transforming the types. So for example, we could say that utility is equal to theta 2, or we could say that utility is equal to log of theta 2, but theta 2 hat, but theta 2 hat is equal to the exponential of theta 2, right? And so there's always an arbitrary number of different ways that you can parameterize the exact same thing by different transformations of the types. And so you always, to normalize for that, have to divide by the derivative of utility with respect to theta 2.
it's like the marginal rate of substitution. Where
Exactly.
Like a positive monotone trend.
Yeah, it's like the marginal rate of substitution between x and theta 2, or theta t in the more general case.
Eliminate those.
Exactly. So, by the same logic, the number of marginal consumers is going to be the integral around the boundary of the density, but divided by the rate at which utility is affected by theta t. So we always have to normalize for any of these integrals by by the derivative of utility with respect to theta sub t. Okay, so more generally, what we can write is that the derivative of quantity with respect to x is going to be equal to the number of marginal people multiplied by the integral of the derivative of utility with respect to x divided by partial u partial theta t times the type, divided by this same expression if we just eliminate u prime, right? And the way I got that was just multiplying and dividing by the number of marginal people. And so that gives us that the derivative of q with respect to x is the number of marginal people times a certain notion of the average utility of the marginal people along the boundary. Now that the relevant notion of the average utility of these marginal people, though, is not with respect to the standard measure, just f of t, but with respect to this one that normalizes for the rate at which the type changes into utility. And that normalization is precisely the one that makes at every point you're moving in the same amount in the willingness to pay space when you increase theta t. So you're like normalizing for the fact that at different points theta t might change the willingness to pay by different amounts. And this alternative notion of the expectation I'm denoting in these slides just by the expectation, but it's not really the expectation. It's the expectation in the willingness to pay space, not the expectation in the type space. As a result, in the paper we put a little subscript u on this because it's in the willingness to pay space, and that's the main mistake I think that's in these slides.
So that means that that is the normalized expectation.
Yeah.
So also for so what we're trying to do here is to see how many marginal consumers will come in if we increase the quality by 1 unit.
Exactly.
And M is just defined as that,
As
the
the
same effect with respect to price.
exactly.
Which is another characteristic.
Exactly. So price is sort of like the baseline characteristic, which we sort of think of as being quasi-linear to define all other effects with respect to that.
That's where you're using price and
Exactly. Okay, so we can now define an inverse demand for the monopolist as being price, which depends on X and Q, right? And the way that we do that is we just invert the relationship between price and quantity, right? So again, Arvid, this is why I'm going to be using this a lot, is I'm going to be talking about inverse demand. And so price is going to play sort of a special role here. Okay, so then profits are just going to be quantity times price minus cost. And so we can just compute the standard marginal revenue is equal to price times quantity plus quantity times the derivative of price with respect to quantity is equal to marginal cost. Now that's not all that interesting because we've spent the last 2 lectures going through this, right? So the thing I'm most interested in is the derivative with respect to X, right? So to figure out the derivative of price with respect to X, remember we have to hold fixed the quantity, right, to get the partial derivative of price with respect to X. So to do that, we need to have the quantity be held fixed at quantity Q, right? But quantity itself depends on X and on price, which depends on X. So we need to solve out from this equation for the partial derivative of price with respect to X. And Matt is not here. Right. Or no, Matt. Oh, sorry, Matt O'Keefe? No, he's not here. Okay. Anybody else want to try to derive that? Yeah, Connor.
Is it negative partial with respect to big Q? dq dx times dp dq.
Okay, I think you should do it on the board. It's just so people can see what you're doing. That might be right, but I learned from the experience with Tova that for these implicit differentiation, it's really hard to tell without writing it out.
So the 16.
Yeah.
Just differentiating both sides with respect to x.
Yeah.
So then it's delta q delta x plus delta q delta p
Yeah.
times delta p delta x equals 0.
Yes. Good.
So then that implies that this equals delta q over delta x negative that times delta p over delta q, which I guess is just negative delta p over delta x.
So you needed to divide through by something, right? You need to divide both sides through by delta q delta p, right?
Yeah, which then.
Oh, I see. That's what.
And the base cancels.
I see. Yeah, that's right. So, but let's just call this 1 over delta q delta p rather than delta p delta q. Okay. So, and remember that we calculated that negative partial q partial x divided by partial q partial p. So remember, partial q partial p is just m. It's the number of people along the margin. And so if we divide partial q partial x by negative of this, we get the expectation of the average marginal utility of marginal consumers. That's how much the price has to change in order to hold fixed the quantity, right? Price is going to have to rise by the average valuation of that quantity by the marginal consumers. Does that make sense? So in order to keep the same number of people buying the good, we have to raise the price by the average over those marginal people of how much they value that change in X. Otherwise, more people will buy the good. If you raise it by less than that, there will be more people buying the good. If you raise it by more, there will be less people buying the good. Okay. So we can now use this to derive the profit maximizing price and social welfare maximizing price. And what we're going to do is hold fixed the quantity. Because we already talked about the quantity distortion, right? That was the focus of the previous class. Now we want to say, holding fixed the distortion of quantity, how does the monopolist distort these product characteristics, right? So total welfare is just the integral over all people who buy the product of the utility they get from it minus the cost, right? So now applying Leibniz's rule, Sang's not here, right? No. Does anyone else oh, sorry. Is Luke here? Oh, Luke's not here. Huh. Anybody else want to try to derive this using Leibniz's rule? Yeah, Kevin.
So in this case, wouldn't Q fix when nothing happens on the boundary at all?
Mm-hmm.
Or is
Why is that?
because you're not going to be moving people along the quantities. So like the line isn't going to be shifting back.
Well, if you leave the quantity fixed, the people who most value along the boundary, the people who most value X are going to be attracted. And the people who least value X are going to be repelled. So it's true that like overall the line's not going to move, but it's going to move like in some places, and it's going to move up in some places and down in other places, right? But there's still something to your argument. Can you? Well, look, what am I integrating here? I'm integrating utility. And what's the value of utility for everyone along the boundary? Right? So any change that holds the total number of people fixed is going to make no difference, right? That it'll all cancel out, right? Okay, so the boundary stuff doesn't matter there, right? So can you figure it out then?
Yeah, so then you just have that integral with u prime of x.
Yeah?
Theta, f of theta, is
Well, you've also got to take the derivative of cost with respect to x.
minus the derivative of cost with respect to as well.
Yeah, that's absolutely right. So there's no boundary effect because Q is constant and all the people have the same utility. If people differed in their utility along the boundary, then it would matter because that could relate to how they value X, right? Okay. Yeah.
Can I go back to the earlier equation of like minus the delta Q delta X?
Yeah.
Q. That's like marginal rate of stuff. Like if you use the same graph with theta 1 and theta 2.
Yeah.
But instead of like utility, you put like distribution. Is that like the marginal rate of substitution along your
Of the total number of people.
total number of people?
Yeah, exactly. And that's the average marginal utility of the marginal consumers. Exactly. Okay, so this is the total number of people times the average marginal utility among all the consumers, right? Because the integral is equal to the number times the average, right? And so that gives a simple social optimality condition, which is the average marginal utility of all the purchasers of the product has to be set equal to the per person marginal cost of providing. That makes, I think, intuitive sense, right? Now let's figure out what would maximize profit. So Albert, what's the derivative of profits? Profits is quantity times price minus cost. What's the derivative of that with respect to x?
You have the quantity and the derivative of b in terms of x, and minus the derivative of c in terms of x.
And what's the derivative of p in terms of x? We derived that on the previous slide, right?
It's the average marginal utility.
Of the marginal consumers, right? Rather than the average consumers, right? So what is going to be the optimality condition then? Can someone say? Yeah, Jack.
The monopolist only cares about the average marginal utility of the marginal consumers instead of the average consumers. So basically replace big delta with delta.
Exactly. So we now have that the per person marginal cost of producing the thing is set equal to the average marginal utility of marginal consumers rather than the average marginal utility of all the consumers, right? So, and the monopolist, that is going to cater to marginal consumers rather than the average consumers. This is also called the Spence distortion. Yeah, go ahead, Lancelot.
I was just surprised, but I mean, mathematically it's obvious, but why, if the monopolist care only about the people on the margin, why do we multiply it by Q and not by M? But I guess it's a change in price.
Yeah, because he changes price multiplied by his quantity. Yeah. So he might set either too high quality or too low quality, depending on whether the marginal or inframarginal consumers value quality more, right? Now, there may be more intensive margins along which the inframarginal consumers might be able to sort of complain about getting something that they like less, and we're going to study those later. Those things are called voice, or like other ways of reducing how much or how actively you participate with the product in response to getting a lower utility from it. Okay, so this is the basic logic. This is sort of the most general version of the logic of price discrimination. What you want to do is squeeze as much value as you can out of the inframarginal consumers without alienating the marginal consumers, right? This is really what we just talked about in the most basic monopoly stuff. You know, we want to extract what we can from those inframarginals, but we don't want to alienate the marginal consumers, right? And the classic example of this is treating consumers who are locked into your product differently than consumers who are more flexible in the use of your product. So for example, cities or countries are often accused of being obsequious to people that they're trying to attract there, like tourists, but then totally screwing over the people who live there. And there's a famous Israeli joke about this, because Israel was trying to attract a lot of Jews to live there, but maybe it wasn't such a great place to live. And so they used to tell a joke that when David Ben-Gurion, the founder of the state of Israel, went up to God, that God said to him, look, I'm going to let you choose. Do you want to go to heaven or do you want to go to hell? And so he said, well, let me look at both of them first. So he goes down to hell, and they're having a party. There's all these, beautiful women, they're all getting drunk and listening to great music. It's like the Berlusconi administration, right? And then they go up to heaven, and they're talking about product design and quadratic voting and the future of the state of Israel. It's like the Obama administration up there, right? And he says, I've lived such a sober life, I deserve some fun in the afterlife, I think I'm going to go to hell. And so immediately they throw him onto the rack, they start pulling out his, toenails and waterboarding him. Now it's like the Bush administration, right? And he says, Lucifer, what gives? I was here 5 minutes ago and it was so much fun. And he says to him, well, then you were a tourist, right? My uncle first told me that joke because he said that when you go to a fancy restaurant, often you'll see a couple and initially when they're going out, the guy will be like, I'm so strong, I make so much money in my job, look at me. And the girl will go, oh, that's so great. You know, and then 5 years later, you'll see him, and he'll still be doing the same thing, and she'll be going like, shut up already. And you know, he wants to say, well, you know, then you were a tourist, right? So, there is a trade-off, of course. So in this model, the only thing you need to worry about is losing someone as a consumer entirely, right? But often there are two other really important considerations. One is that people might buy less of the thing that you're selling if you don't treat them well, right? You're not just worried about having them at all or not, it's like how much they're buying from you. And second is that there might be the wrong sorts of people that you might attract if you're screwing people over. So you might attract a lot of gullible people who wouldn't be so great to have, rather than the people who are most valuable to you, right? And that's what exactly the two other effects we're going to talk about deal with, the Musa-Rosen and Vega-Weil effects. Yeah?
So what's the difference? Like, is that only the multidimensionality that makes a difference between the first problem set we had and this? Like, first problem set we had, the firm chooses the socially optimal quantity.
Yes.
Quality, sorry.
Yes.
And here they choose a different.
It's the heterogeneity. Heterogeneity of the valuation of quality. In the other one, everyone had a homogeneous valuation of quality. So heterogeneity is really what this lecture is all about. It's all about how things, what effects come out of what areas of heterogeneity. Yeah.
And because so in our problem set case, the marginal valuation of the marginal consumers
was the same as everyone.
Was the same as the,
because everyone was completely homogeneous in their valuation of quality. Everyone viewed quality as one-for-one exchangeable for price. Yeah, Oliver.
So why doesn't this model deal with intensity of consumption? Because we just have a market demand curve here, right?
Yep.
But we could consider the market demand curve to be like an aggregation of individual demand curves where every individual has like a...
Well, that's not what I assumed up front, right? So in the abstract, you could interpret it that way.
Yeah.
If you only look at my final things, but I give a micro foundation for those things in terms of the integral of purchasing decisions of individuals.
Okay, yeah.
And I couldn't interpret that thing as the average marginal utility of marginal consumers otherwise, because it's not equal to the average marginal utility.
The average marginal utility of the marginal consumption.
A marginal consumption decision, I guess.
Yeah.
You could call it that. Yeah. Okay. So the most famous model of product design was by hoteling. So before we turn to those other effects, I'm going to talk about the hoteling model, which really is one that lives in this world. And the product characteristics are along a line like the consumers. So consumers live along a line, and the product characteristics are determined by your position along a line. And you can think of this as the location of a store, and consumers are distributed, let's say, uniformly along the line, and they have to travel to the store, right? So consumers always buy one of the two competing products. So it's not technically a monopoly scenario, but the logic is going to be very similar to it. Each firm is going to start living somewhere along this line, and then the question is, from wherever they start, where are they going to choose to move? Winnie, imagine that you have two firms, they're somewhere along the line. Where are they going to choose to move along this line?
Towards each other.
Why?
Because if one firm, so everyone, if the consumers all like choose based on how far they are
Yeah?
from each of the firms, then the middle consumer is going to be different, and one moves a little bit towards the other is going to be different.
Exactly. So that's going to be the marginal consumer, right? And we said that firms are always going to cater towards the marginal consumers. Because the marginal consumer is the one that's halfway in between the two of them, firms are going to move towards each other in order to try to move towards what's preferred by that marginal consumer. And they're going to disregard the preferences of their inframarginal consumers, right? Okay. So here the marginal consumer is halfway between you and your competitor, so you always move towards your competitor, but this holds at every point, and so you have to wind up at the same spot. Now, Can anyone say where that spot has to be? Tova.
It's like right in the middle.
Why?
Because if you weren't right in the middle, then you can definitely always gain a consumer by moving just one unit closer to your competitor. And then maybe he can gain a consumer moving one unit closer to you.
So that means you end up at the same spot, but why couldn't you end up at 0.75 rather than right in the middle?
Because your competitor is getting, because he can then gain, because you're not getting half the market, because he'll be going the other direction.
So if you just move a little bit towards his side, you can get all of his consumers then?
Because you want to get as many consumers as possible. And that's the best place, unless he is off-center.
Well, if you're both at 0.75, if you move just slightly towards his side, then you get all of those consumers. Yeah, and you only lose the ones that are, yeah, exactly. So here's the little picture of Hotelling's beach. So here are like the two people, and they're going to converge towards the center, because if they were over here, well then this guy's lemonade stand would just move a little bit. He would get all the people on that side of the beach and leave his competitor with only the ones on the other side. Okay, so in this simple model, in this simple Hotelling model, both firms end up at the center of the line. This is an extremely famous result, right? And it's suboptimal because both, like on average, consumers would be better off if the firms spread out, right? It's like not all that convenient to have just two guys sitting in the center, right? But no firm is going to do this, and in fact, a monopolist would do better. And this is an idea that's very widely applied and very relevant in geographic settings, but it's not necessarily the right direction, even in the geographic setting. Yeah, Vitor.
I'm taking game theory right now.
Yeah.
You learned a Hotelling's model of a qual competition.
Yeah, we're about to do that. We're about to do that. Yeah.
Wait,
Yeah.
so why would you say monopoly would do better? What do you mean by that?
So if you're a monopolist, you wouldn't locate them both at the center necessarily.
You don't have one store because you don't have to have it.
Well, but imagine you had two stores and you could operate both of them and coordinate your decisions.
But in terms of like social optimum, monopolies like would in fact is worse because like you have the option because they have no obligation.
No, I mean that's not true. I mean the monopolist.
No, because the monopolist can then put his instead of being at 0.5, he'd be at 1 or 0, and then everyone.
No, but why would he do that? I mean, his profit, like the thing that would maximize his profit, if he has any chance of losing any customers,
Right. Oh, but then
even a tiny bit, he'll always want to locate at the efficient spot.
okay.
Yeah. Yeah, Donnie.
Is there any way you could use some kind of co-seam bargain where you just say like, oh, I'll pay you, we can pay each other to, or there would be some way to work out a contract so that you each stay in your respective spots. You both.
Well, that would be collusion. So yeah, I mean, you could allow that, and that could be beneficial here. But, okay, so, but if we start, as Tova was getting at, thinking about a case where maybe there are some consumers that don't buy the good at all, if the consumers that don't buy the good at all, if there are consumers that don't buy the good at all, well, things might not exactly go in this direction either. So for example, imagine that the consumers here could get fed up and just not buy anything at all. Well, that'll push you back towards that side. Or imagine that you imagine that there's like some product characteristic other than your location, like how much ice you put in your lemonade, right? Then there might be people at all different parts that decide they don't want to buy it because it is too much ice or the price is too high or whatever. And then the key question is going to be, are the people who are just indifferent, who are over here between the two goods, more or less representative of your average consumers than the people who are definitely going to buy your good, if they're going to buy any of the goods, but might be indifferent between buying your good and buying nothing at all, right? So the competition is going to force you to attend more to the people who are in the middle, right? But are those more or less representative of your average consumer? It's not completely obvious, right? Nonetheless, I think the Hotelling model gives an interesting way to think about things and a useful baseline, but the more general logic is you always attend to your marginal consumers. And those need not be the ones that are switching between you and the other firm. They might be switching between you and having nothing. And then it's all going to depend on, where there are more marginal consumers and how intense the competition is and so forth. Okay, so maybe the most famous application of this is what Vidur was emphasizing, which is the model of spatial competition in elections. Yeah. Tova.
Wouldn't, in any dimension in which you're competing, wouldn't you both, I think it's the same thing as well, like wouldn't you both firms just come to the same conclusion? So whether it's spatially or in terms of how much ice you put in for your price?
Well, no, because the thing is that once I'm on this side of the space and you're on that side of the space, we might have different marginal consumers. Now, if you have the same, if your marginal consumers have the same value, yes, you would choose the same amount of ice. But the question is, would that amount of ice be optimal or not, right? And would competition make it better or worse that ice was optimal? Like, would it make it closer or further from being optimal? In this model, monopoly always brings you closer to the optimum. But it doesn't necessarily always do that. It all depends on whether the consumers that are switching between the two firms are more or less representative of the full population of consumers than are the ones, yeah. Okay, so imagine that there are two political parties that are competing and they're choosing a position left to right. And everyone is going to vote, but it's just a question of who they're going to vote for. So as a direct extension of Hotelling's logic, what should we expect to happen in this sort of competition? Lancelot?
So both the left-wing and right-wing parties are going to try to design a program so that it satisfies the median voter?
The median voter, the one who's in the middle, right? So both political parties will adopt the position of the median voter who has an equal number of voters to the left and the right of her. So this is probably the most fundamental result in all of political science. It's called the Downsian model. And it also matches a lot of common sense intuition. In a two-party system, everyone sort of is going to run to the center, right? Another subsidiary version of this intuition is the more competitive the electoral system is, the more towards the center people are forced to run. But this is all very simplified, and there's a more general principle that lies behind it. So what are some of the things that, in the real world that are missing from the median voter model, Albert?
It's the same. Some of them they are more like they are not uniformly distributed around those political thoughts. Like some a lot of people get clustered in one.
But it's still going to be the case that you're going to run to the median voter, which is the person who has half of the people to their left and half of the people to their right. But what I mean, this was a very simplified model. What do you think are some of the important features of the world that it leaves out? Well, that would screw up this logic.
Not everyone will vote.
Yeah, not everyone necessarily votes, right? We assumed here everyone votes. It's just a question of who they vote for. So there might be an issue that you have to worry about people not voting, right? So another thing is that voters are in one dimension here, right? But people differ in lots of different things, right? Like, people aren't just described by how left-wing or right-wing they are. There's social conservatives, economic conservatives. There's national defense. I mean, there's tons of issues, right? And also, not everybody votes, right? You need to make sure that people actually turn out, right? And you can use the logic of catering to marginal consumers much more generally. So more generally, it's not median voters that are the target, but swing voters. And in particular, there might be different groups of swing voters, right? There might be the fiscally conservative but economically liberal people, but socially liberal people, and then there might be the socially conservative but economically sort of socialistic groups, right? So these groups in the U.S. politics are called sensible centrists for the first group and the radical middle for the second group. And different parties, different policies might attract these different groups. And the core of political strategy is sort of how to grab some of each of these groups without alienating the other set of marginal consumers. Yeah, Oliver.
I suppose which one's the sensible and which one's the radical depends on the political views.
Yeah, I mean, the reason is these types of people tend to be part of the elites. Like they tend to be people like us, and these tend to be like poor white people in the who don't read the New York Times, and that's how they got these names. The parties also tend to cater to their base because they're afraid that people might not turn out. So Munsu, how would that come out of the model? So how would it come out of the like logic of catering to the marginal consumers that you might worry about your base?
What does it mean base?
Your political base, like the people who like are definitely don't like your opponent, but how would the fact that people might not turn out lead you to worry about your core constituency? Think about the hoteling model and what we were saying was going on there.
What does it mean that may not turn out?
So like turn out to vote,
Oh,
who might not show up at the polls. So like, people are trying to get people to vote for them, but they're also trying to get their base to turn out, and vote. Turn out to the polls.
yeah.
Does anyone else want to? Yeah, Oliver.
So you imagine at the margin you move a little bit in one direction, you'll isolate voters on one side, you'll lose voters to the other party.
Yeah.
If you move a little bit to the other direction, you'll lose voters to not voting, not caring, and you want to balance those two.
Yeah, so that's sort of similar to what we were saying was going on in the hoteling model, where you could lose people at the end of the beach, or even at every point of the beach, there might be some people who, even though they're at that point, like are more or less motivated to vote, right? And the fact, like, you want to get people within your side more motivated to vote might lead you to cater to their views as well. Yeah, Lancelot.
I was wondering if does that like sort of internalize the intensity of voters a little bit?
Yeah, it can. So there's actually a nice paper by from the 80s by, what's his name? John Ledgard, which shows that under some very, very strong conditions, actually for reasons very closely related to quadratic voting, you can get efficiency that way. So in particular, if there's a very large number of voters and very, very few of them vote, so they're perfectly rational, right? Because they know they can't be pivotal, and they have a cost of voting which has some density, so there's no mass of people that have no cost of voting, and there's no mass of people who have negative cost of voting. So you already see these are very unrealistic conditions, but if that's true, then you get something very similar to quadratic voting, because basically what happens is that near zero, if you have some density there, like it's locally uniform, and that means that there's like a representative person with every strength of preference, and they can sort of choose how many of people like them will vote, and that'll create like a quadratic cost. You see what I mean? And that basically mimics quadratic voting. So you get efficiency in that case.
But even without those conditions, you can.
Yeah, more generally, you'll tend to get closer to efficiency. Yeah, Oliver.
So the narrative you always hear about the American politics these
Yeah.
days is that basically all the electoral districts have been gerrymandered such that, I guess, to win primaries you need to be catering to a voter distribution which is very different to the voter distribution you need to cater to win elections.
Yeah.
And so, I don't know, I'm just saying, what can we say about like that kind of two-stage game from
Well, I mean, I think it represents a lot what you see, right? Is like, you're maximizing two things. You're going to do some weighted average of the two marginal voters, right? And you'll probably try to reposition over time. So yeah, I think you can get a pretty nice, I mean, I think that this sort of analysis is like not used nearly enough. Like there's not, in political science, you don't see these like multidimensional heterogeneity type models showing up, but I think they're like extremely realistic, and they really help you understand like the fact that swing voters are not all the same, and you do these micro-targeting and all that sort of stuff. So, okay. So, Jenskow and Shapiro also use this model to study media slant. So they look at local newspaper monopolies around the United States, and they score them on a single left-right dimension. But it's one firm, so it's even more like Spence. And they measure slant by the language used in the newspaper. So how do they do that, Jack?
So they take the congressional record and look at what Republicans say and what Democrats say.
Yep.
The same thing, like say death tax versus estate tax.
Yep.
Tax breaks versus tax hikes.
Yeah.
And tax extra beef, yeah, exactly.
Yeah.
And then, so they can match that up to what newspapers then say. So
Yeah.
supposedly the identification is that newspapers that use the same language as Republican congressional leaders are more Republican.
Exactly. Exactly. Republicans use death tax, illegal aliens. Democrats use poor people, workers' rights, tax breaks. And then they break different local markets into districts that have different politics. And they measure which districts do and do not read the newspaper. And then they use this to construct a model of how much people care about how the slant corresponds to their political views. In particular, they look at how much more left-wing newspapers are read less in right-wing zip codes. Like you basically take two equally right-wing zip codes in different cities, and then you see as the newspaper moves left to right, how does that change readership, right? And this shows how much value people put on slant, and therefore what would maximize profits, right? And the interesting thing that they find is that the newspapers, what maximizes profit does a pretty good job explaining what newspapers do, but once you've controlled for that, the ownership of the newspaper, the political contributions of its editorial board, none of these things make much of an impact. And therefore they claim that mostly these newspapers are trying to maximize profits. So this shows, if you look at the percentage of a market that's Republican, it does quite a good job explaining the slant of the newspaper. Okay. So, an important thing to notice in this example is that most of the profits that newspapers make are not actually off their readership, but off of the advertisements that they're able to sell. So therefore, readers are really not just valued as consumers, they're valued as the producers of another characteristic of the platform, of the newspaper, which is how much readership they have, which is what they want to sell to the advertisers, right? So rather than calling people consumers, in this context, you might call them users. And in that setting, we say that the firm is a platform because it uses its consumers. All of its consumers are also producers in some sense, producers of other characteristics that they use to sell to other consumers. This is also sometimes called a network or a two-sided market. And there's tons of examples of this type of thing. They're increasingly an important part of the economy. Robert, could you give some examples of platforms?
As far as where they have users' ads.
Where they use their consumers or their users, to both as consumers but also as people who produce value for other users of the system.
I guess like social networks.
Mm-hmm. Those would be a classic example, absolutely. Another example would be any media platform, newspapers, television, websites, because they primarily get their profits from the advertisers, but they use the readers in order to generate that. Payment platforms like credit cards, debit cards, PayPal, etc., because they primarily make their profits off of the merchants, but they get people to use the cards in order to charge the merchants for them. Operating systems like smartphones and video games, they have two different clientele. They've got, if you're Apple, you've got to attract people to develop apps, but then you also have to attract people to buy the iPhone to use the apps. Any transaction platform, more generally, dating websites, yellow pages, etc. And the same Spencean logic applies to this, and that's what some of the papers on your syllabus talk about. Yeah, Tyler.
What about would another example be, say, sports fans, the game, like Coast fans versus Sox fans, liking particular types of beer, maybe, and when they purchase it, like their preferences when they go to a game, like which stadium they pick?
Yeah. So I don't think that's quite as important because I don't think like the food and brands there play as important of a role. Okay. So I'm not sure I would analyze it primarily that role.
Like a lot of stadiums are sponsored by different companies.
Yeah, I think that's probably like a smaller fraction of their revenue, but yeah, I mean, there's tons of industries that are like this. So I don't really believe that you should be like in the business of saying, oh yeah, this is a two-sided market and this is not. It's really more like this is an important issue in certain industries, and in other industries it's less important but still there. Yeah, Kevin.
Would you consider it a two-sided market if the product was like handed out for free to like one side?
That probably means these effects are important if something that's costly to produce is being given for free. Yeah. Okay, so now let's return to the concerns that we had earlier about the intensity of purchases. So, if in the initial model you either buy something or you don't buy it, but if you go to a store and then decide how much to buy, if the store sucks, you might still go, but you might buy less stuff there, right? So in this case, because I don't want to introduce directly the purchases, I'm going to put it into the cost function. So now the cost of a user is going to depend on the utility that they get. So if you're giving someone more utility, then they'll be less costly to you or more profitable to you equivalently. So in that case, the value you get is equal to the quantity. The cost is going to be equal to the quantity times the average cost of the people who buy your product. And individuals with utility greater than 0 may decrease the cost or contribute to profits. You could also call this moral hazard or the intensive margin. Then the derivative of cost with respect to price is going to be the number of marginal people times the average cost of marginal people. But it will also, and that'll be true when you take the derivative with respect to price. But when you take the derivative with respect to the non-price characteristic, that will impact both the people you get on the margin, proportional to their marginal utility, but also it will impact the cost of the inframarginal consumers by changing their utility as well as directly changing the cost of serving them. Because changing their utility changes the cost. Now, for all the people along the margin, they are going to have the same utility and therefore the same cost. And so you get two effects. There's a direct increase, and of course, holding fixed the quantity, that's not going to, because these people all have the same cost, because they have the same utility, there's going to be no effect once you hold fixed the quantity. But there are two inframarginal effects. One is the direct increase in cost when you change the quality, but then there's also an indirect intensive, this should be intensive margin effect, extraction effect, where if I increase the quality, I'll give people higher utility, and that might reduce the cost or increase the profitability of consumers because they're willing to buy more when the quality is higher, right? And this basically just replaces the partial C, partial X term from before. So a classic example of this is if you provide higher quality product, consumers will be more loyal. That'll lead them to come back more. They'll buy more products, or they'll be less likely to default on the loans that you give them if you make a better term on the loan for them. Okay. So this is along the intensive margin, but then there's also an incentive that disciplines your ability to extract from inframarginal consumers that comes from the extensive margin, which is that different consumers may have different costs and therefore may be differentially attracted. So the simplest way to model this is to make cost, rather than just a function of your utility, a function of your type in general. And that simplifies down the double dependence from before. Now when we take the derivative of cost with respect to x, we'll get two effects. One, we'll still get this intensive margin thing, that as you change x, you're going to change the cost of people for all the inframarginal people. But now the people that you're going to attract are not going to just be anyone on the margin, but particularly the people that have high marginal utility for x. because the rate at which you attract them will be weighted by the rate at which the boundary is changing, which is the marginal utility that people get from X. Now, in order to hold fixed, this should be Q, in order to hold fixed the number of people, you're going to have to raise the price, right? And the amount that you raise the price is equal to the average marginal utility of the marginal consumers, because that's what holds fixed the quantity. And that will reduce your costs by the number of people along the margin times the amount you change the price, multiplied by their average cost. So we get an increase. God, there should be a negative here, sorry. This isn't all multiplied together, there's a negative there. You increase the cost by the number of marginal people times the expectation of the product of marginal utility and cost. But then you reduce your costs by the people that you repel, which are proportional to the amount you increase the price, the average marginal utility, and their average cost. And now remember that the expectation of a product is minus the product of the expectation is equal to the covariance. And so you're going to get the number of people along the margin times the covariance between marginal utility and cost along that set of marginal consumers. And that is going to be the sorting cost of increasing X. So to the extent that X selectively attracts people with higher cost, there will be a positive covariance between marginal utility and cost, and that will deter you from increasing X. Right? So it's still going to be the case that you're going to have this intensive margin effect. And this is exactly the general Vega-Weil model. It puts together all of these effects. And a recent very nice application of this was by Laurent Einav and co-authors. And they looked at these two different ways in which your ability to just extract from consumers would be disciplined in the ways we just described. In particular, they looked at how you would change the profitability of consumers you already have and how you would selectively attract different consumers. Or at least their model looks at that, though they don't describe it that way, and this is something that Jack is looking into. So in particular, they looked at loans to consumers, and they looked at different dimensions of these loans. In particular, the down payment that was required and the total price that was charged to the consumers. And of course, different consumers were charged different things based on their observable credit scores, but there are also hidden risks that the credit score might not capture. And changing the required down payment is going to therefore affect, in two ways corresponding to what we've already talked about, the chance that consumers might default on their loan. Because of course, if you make them a loan, there's, especially in the subprime market, which is the one they focus on, there's a good chance that they won't end up paying you back. And what are the two ways that it might affect if you increase the down payment, let's say, what are the two ways in which that might affect whether someone's going to default? Can someone say what are those two ways? Not Jack, because he's working on this. But, yeah, Kevin?
So, for the intensive one, it would be that like a changing down payment would make more of the debt being paid upfront. So less of it is like available to default.
Exactly.
In some sense. And extensively, it might sort for, so like the down payment's higher, then people would be less likely to take on that debt if they're less likely to pay it back in the future because they'll have less cash and therefore less ability to pay that down payment.
I mean, more generally, just people who have more cash on hand are less likely to default in the future.
Okay.
Right. Yeah. And so Einav et al. Look at variation in these requirements that they claim the firm did basically randomly. And what they show is that increasing the sticker price is often counterproductive because it ends up translating pretty directly into debt. So that's a version of the intensive margin. And because it translates directly into debt, people end up defaulting more frequently. But on the down payment, what they show is that one of the really, really big effects is that it selectively is attracting people who are less likely to default. And just to show you that, so here's a version corresponding to the graph that I showed you earlier. So imagine people differ along two dimensions, the initial value of the car that they're buying and the liquidity that they have initially. If you raise the price, the people who are going to stop buying are not going to be the illiquid people because they think they're going to default anyway, so they don't even really care if you increase the price, right? Whereas the people who are going to be affected are people with large unobserved liquidity. Those are the people who are going to stop buying. On the other hand, if you raise down payment, the people who are going to stop buying are going to be the people who have a low liquidity because they're not going to be able to afford that. And so that means that when you change minimum down payment, when you increase it, the probability of people defaulting goes down because you're selecting people who are more valuable. And that's going to mean that even though that decreases the chances of you making a sale dramatically, it's still going to be in your interest to do that. On the other hand, when you increase the price, even though that's going to make you more money in principle, it's going to dramatically increase the probability of default, and that's going to lead you not to want to charge too high of a price. Yeah?
So I'm not that clear on like what exactly happens when a consumer defaults. So like from a consumer's point of view, is it worth like taking out a loan knowing that you'll default?
Maybe not, but taking out a bigger loan is certainly not a problem if it's going to, like in other words, like just the act of defaulting is bad, but how much you default by doesn't really matter. And so that's why someone who thinks there's a good chance they're going to default is not going to care very much about the price. Yeah, Tova.
I was just thinking when it comes to like home ownership,
Yeah.
taking out mortgages. I mean, now it's decreased a little bit, but a couple, like 4 years ago, when like home affordable programs were
Yeah.
like that was a tremendous impact on like purchases and defaults. Again, that was just the same thing.
Yeah.
So, like, as people were just much more likely to default and much more likely to purchase homes way out of there, even if it was sticker price way above range.
Yeah, that's definitely true, and that's like something that you could look at as well. Is like the selection into getting a loan at all based on these government programs if you had some variation in them. Yeah, Miles.
Price not affect the probability of sale on that last round.
Yeah, it's kind of amazing. I think that it's just because basically people are so illiquid that they're expecting such a high chance of default that they're not that sensitive to it. But that's what appears to be happening in the data. Yeah, Russell.
What's the sticker price in that sector?
The sticker price.
Using the sticker price was counterproductive or something.
Oh yeah, sticker price is just like what you allegedly have to pay, the alleged price. But I mean, that's like, but it's like all gonna end up as debt, and then you're like, you default on it, it doesn't really matter. That's the idea. Okay, everybody, you've got a midterm. Good luck with that. And I'll see you guys all on Tuesday.